This DVD will discuss some basic principles of biosecurity for aquaculture facilities and guide you through the development of your own HACCP-based biosecurity plan. It is brought to you by the North Central Regional Aquaculture Center and the U.S. Department of Agriculture National Institute of Food and Agriculture, with the participation of the University of Wisconsin Extension, the University of Wisconsin-Stevens Point Northern Aquaculture Demonstration Facility, the Center for Food Safety and Public Health at Iowa State University College of Veterinary Medicine, and Michigan Sea Grant. This program will begin by outlining the basics of what biosecurity means for a fish farm, what it looks like in practice on several types of fish farms across the North Central region, and conclude with a discussion of how to use the hazard analysis and critical control point, or HACCP technique, to develop a biosecurity plan for your aquaculture facility. Fish diseases continue to be one of the greatest causes of economic loss for the aquaculture industry, accounting for millions of dollars in annual losses to the U.S. fish producers. The concentration of large number of animals within production settings can lead to the rapid spread of disease. High stocking densities increase stress, making fish more susceptible to bacterial and viral infections. Since treatment options are limited for most aquaculture diseases, prevention remains the best line of defense for the aquaculture producer. Biosecurity is the first and most important step in reducing the risk of disease introduction or spread on your farm. Biosecurity measures help promote fish health and protect your economic investment. There are a number of regulations and trade requirements for fish, as well as a growing demand for specific pathogen-free fish. Many times these requirements involve the implementation and documentation of biosecurity procedures on the farm. Maintaining healthy fish and acquiring pathogen-free status can improve or ensure a producer's reputation for providing a high-quality product. Biosecurity measures can also protect stocks against new and emerging diseases such as VHS, viral hemorrhagic septicemia. Prior to 2005, VHS was considered a disease of salmonids. However, in 2005, a new strain of the virus was discovered in a number of important commercial and sport fish in the Great Lakes region. While to date this new strain of VHS, VHSV, has not been found in any aquaculture facilities, the spread of this disease could be catastrophic to the industry. One final reason for implementing biosecurity measures is the protection of human health. Although most zoonotic diseases of fish are food safety issues, there are some fish pathogens that can cause illness in humans who have been in contact with infected fish. Biosecurity measures for your facility will depend on a number of factors, including the type and purpose of the facility, as well as the species and life stages reared. There is no one-size-fits-all solution. Determining the needed biosecurity measures will involve identifying risk areas for your facility and then identifying effective preventive measures that obtain the greatest cost benefit. Most preventive measures are inexpensive when compared to the potential loss that can occur from fish deaths, decreased production, or the need for depopulation following a disease outbreak. Many procedures are quickly implemented, such as posting signage and placing foot dips in disinfection tubs. Other measures may involve variable levels of economic investment or effort, such as purchasing steam disinfection equipment and providing dedicated quarantine equipment or facilities. Work with your veterinarian or fish health specialist to identify risk factors and develop an effective biosecurity plan for your operation. Once determined, make sure these measures are communicated to others involved in your farm, such as your employees, delivery personnel, and visitors. Assessing your farm for the needed biosecurity measures first requires a basic understanding of how diseases can be spread on your farm and the various risk factors for transmission. This will help you to identify, assess, and prioritize the specific risk areas on your farm and determine what measures will help reduce those risks. Diseases can be spread by fish in a variety of ways. Direct contact is one of the most common routes of disease transmission in aquaculture. This involves the transfer of disease-causing agents through contact with infected fish. It is referred to as horizontal transmission. Entry may occur through the skin, open wounds, mucous membranes, or gills. Some pathogens are spread from a female fish to her eggs. This is called vertical transmission. Disease pathogens can also be transmitted orally by consumption of contaminated feed, infected live or frozen fish, cannibalism of dead or dying fish, or intermediate hosts such as snails infected with parasitic organisms. Ingestion of water contaminated with waste products from infected fish may also serve as a transmission route. Many disease-causing organisms can be transferred through water sources. Use pathogen-free water sources such as wells, springs, or other groundwater sources when possible. Surface water sources should be avoided as they have a greater potential for carrying fish pathogens. If the use of pathogen-free sources is not possible, disinfection of the water supply by ozonation or ultraviolet radiation may be needed. Filtration of water sources can help exclude the introduction of unwanted aquatic species from your water source. Infected fish can contaminate the water sources they are living in. Contamination occurs from the urine, feces, reproductive fluids, and mucus of infected fish. Movement of this contaminated water during the transport of fish can spread pathogens to new locations. A few fish pathogens have been found to spread via aerosols, sprays, or splashes between tanks. This is less common and typically requires close proximity of the sources. Fomites are inanimate objects that can transfer pathogens between rearing areas or production sites. These items become contaminated following contact with infected fish or contaminated water sources. Examples include equipment such as nets, buckets, siphon hoses, any equipment that comes in contact with water or fish. Fomites also include footwear or clothing worn by fish handlers, or vehicles like hauling trucks or tanks that may be used to transport potentially infected fish or contaminated water. Vehicles and equipment should not be shared between sites. If possible, dedicated equipment or vehicles should be used. If this is not possible, these items should be cleaned and disinfected between fish lots or farms. Any residual water or debris should be removed. Bilge water from boats should be removed and disinfected. Vehicle cleaning should include the wheel wells, tires, and undercarriage. Wash stations should be provided on-site away from animal production areas. Any equipment used at aquaculture facilities should be cleaned and thoroughly dried, preferably in direct sunlight, or chemically disinfected before being used in another location. Fish production tanks and raceways should be disinfected between each lot of fish. Construction materials should be non-porous and easy to clean and disinfect. Avoid the use of wood, as it is hard to disinfect completely. If used, it should be limited to temporary structures and should never be transferred to another site. One of the most overlooked and important steps is the removal of visible debris like soil, mucus, waste products, aquatic plants, algae, and uneaten food prior to disinfection. Many disinfectants are less effective and often inactivated in the presence of organic matter and debris. Foot dips should be placed near the entrance to animal areas. Boots and waders should be cleaned and submersed for an appropriate period of time prior to and after leaving the area. Foot dip solutions should be changed daily or when visibly soiled with debris. There are a number of chemical disinfectants available that are effective against fish pathogens. Some can be toxic to fish, so they should be used with caution or in areas away from live fish. Less commonly, fish diseases may be spread by vectors. Vectors are living creatures such as fish-preying birds, mammals, or amphibians that can spread disease pathogens. These animals may transfer fish diseases between locations by carrying the pathogen on their body or feet, or by dropping fish or fish parts at other locations. Rodents may carry fish pathogens on their body or in their feces or urine, contaminating the environment for fish feeds. Domestic animals, such as pets running around the farm, may also serve as cross-contamination mechanisms for some pathogens. Isolate your fish from animals that may present a risk of disease introduction. Biosecurity measures must protect cultured fish from contact with wild species, as well as prevent the escape of infected cultured fish or runoff of the contaminated water sources or effluents. People can serve as vectors by transferring pathogens to fish during handling. Visitors to the farm, especially those coming from areas where they may have been exposed to fish diseases, may also serve as vectors for the introduction of disease to your farm. These individuals should take measures to minimize the potential risk of disease transfer. This includes wearing clean coveralls and disposable or disinfected rubber boots while on the farm. Maintain a log of visitors to your farm. Farm personnel should accompany all visitors on your farm during their visit. When possible, these individuals should avoid animal areas and be restricted from contacting water or handling your fish. Employees should wear clean clothing, coveralls, and footwear when working with fish, and wash or sanitize their hands when moving between areas. Foot dips for disinfecting footwear should also be used between these areas. Employees should perform tasks in areas from lowest risk to highest risk, from least susceptible to most susceptible populations, saving quarantine or isolation work for last. Access to egg incubation and fry facilities should be restricted to a minimum number of well-trained individuals. The movement of fish onto, within, or off the farm is the greatest risk factor for disease introduction and spread in aquaculture. New fish brought to the farm for breeding, grow-out, or restocking may introduce pathogens to resident fish. This may include purchased fish, if not inspected, or eggs, if not disinfected, as well as wild stocks. Fish that have been taken off farm and then returned may also pose a disease risk, especially if they have been commingled with other fish. Keep in mind that for some diseases, fish may be infected without showing signs of illness. These carrier fish can then serve as potential sources of infection to other fish. To prevent disease introduction onto your farm, purchase fish from known and trusted suppliers. These fish should be inspected and found free of important diseases. Limit the number of sources fish are purchased from and the frequency and number of new introductions onto your farm. Once fish are brought to your farm, minimize the transfer of disease to resident fish by isolating new arrivals before adding them to your current stock. This includes fish recently purchased as well as fish returned to the farm. The length of quarantine is variable and depends on the disease of concern. 4 to 6 weeks is commonly suggested. Keep in mind some diseases are also temperature-related, and visible signs of illness may not be seen until optimal water temperatures occur. The quarantine area should be located away from resident fish and should have a separate water source or flow circuit. Any water effluent from the quarantine area should be managed to avoid contaminating water sources or fish production areas. Dedicated equipment should be used in the quarantine area to avoid fomite transfer to resident fish. Care of fish in the quarantine area, such as feeding and cleaning, should occur after resident fish or by an employee assigned solely to the care and handling of the quarantined fish. The impact of fish diseases may result in the direct loss due to illness or mortalities. However, effects may be more subtle, such as reduced growth rates, feed conversion efficiency, or product quality. The susceptibility of fish to disease is greatly influenced by stress. A number of parameters in aquaculture can increase stress in fish, including high stocking densities, improper water quality parameters, and poor nutrition. Minimize stress in your fish by keeping stocking densities within acceptable parameters. Limit transfers of fish between units or locations when possible, and when moving fish, use gentle crowding and fish handling methods. Fluctuations or improper maintenance of water quality parameters can predispose fish to disease. This is particularly true of water temperature, since fish immune systems are influenced by temperature, being less effective at lower temperatures. Many fish pathogens, including VHS, are also temperature dependent. Store feed in a cool, dry place and use within 3 to 6 months. This serves to maintain the vitamin and mineral stability in the feed, as well as reduce the potential for moldy or contaminated feed. Keep feed in areas secured from vectors. Clean up any spilled feed to avoid attraction of birds or rodents. If live fish are used as feed, be sure to obtain healthy fish from reliable sources. Monitor fish frequently for disease. Employees should know the major signs of illness in fish and who to contact when these are noted. Early identification of fish diseases can help minimize its spread and impact on your farm. Ill or dead fish should be removed immediately, as they can serve as potential disease sources to the remaining stock. Dying fish should be promptly removed and humanely euthanized. Disposal should be in accordance with local and state laws and in a manner that predators or wild birds cannot access carcasses and further spread the disease. Ill fish should be removed and placed in an isolated area away from current fish stocks. This area, similar to quarantine, should have dedicated equipment and water sources. Care or treatment of these fish should occur after healthy resident fish. When signs of illness in your fish are noticed, contact your aquatic veterinarian or fish health specialist immediately. Necropsy and testing of ill fish can help identify a potentially infectious disease before it becomes widespread on your farm. Keep accurate records. Maintenance and monitoring of fish production and health records can help detect disease problems and often provide clues for diagnoses. Maintain accurate records of fish illnesses or keep records on fish production parameters such as growth and feed conversion rates. Record all new introductions of fish or returning fish, their sources, and movements on or off the farm. This can help identify potential disease entry points in the event of a disease outbreak. Maintain records of any treatments, vaccinations, or prior disease situations. Above all, keep your records organized. The time your fish health professional spends with you is valuable. Don't waste it by having to dig through random piles of paperwork. Once you have determined the biosecurity measures you will implement on your farm, it is important to communicate these to employees and visitors to your farm. Having a written plan ensures those affected will have access to the necessary procedures and in many cases is becoming a requirement for the inspection process or for transport requirements. Once biosecurity measures are implemented, it is also important to assess how well they are working. Your biosecurity plan is a living document. It should be updated or modified to reflect the needs and circumstances of your aquatic operation. As the aquaculture industry continues to grow, the threat of infectious diseases to fish production facilities will continue. New disease pathogens are being discovered or are spreading to new locations. While the risk of disease in production settings cannot be completely eliminated, the use of biosecurity measures on the farm can help you to prevent disease and protect your fish, your farm, and your investment. The Hazard Analysis and Critical Control Point, or HACCP program, is a tool that you can use to develop and assess a biosecurity plan for your aquaculture facility. The HACCP concept has been used by the seafood industry for over a decade to ensure product safety. It has also been adapted by the Michigan and Minnesota Sea Grant programs to train fish farmers, bait harvesters, management agencies, and researchers to develop biosecurity plans that control the spread of aquatic invasive species, AIS, including pathogens like VHS. Since the HACCP process identifies and protects those critical steps in your production scheme where hazards are most likely to occur, the end result is a cost-effective biosecurity protocol that protects your operation from the most probable dangers. Many of the preventative measures for the potential hazards you may encounter are well known to experienced fish farmers, but documenting these precautions is a useful tool for passing along this information to less experienced employees and emphasizing their importance to your workforce. This part of our presentation will guide you through the development of a HACCP-based biosecurity plan. We recommend that you print out the HACCP forms for healthy fish farms found on the accompanying disc so you can follow along. We won't be going through every line of the process, but we will select areas where questions may arise. The other examples of HACCP plans found on the disc were developed during our HACCP training programs and may be helpful in drawing up your biosecurity plan. The first step in the HACCP process is the completion of the product procedure form. This form identifies the business, lists the species cultured, and the types of activities undertaken, as well as the intended use of the product. Most importantly, the form characterizes the product and procedure flow. This list of specific activities will be the basis for your critical control point analysis. It should be a step-by-step description of the things you do on your farm from the beginning of a production cycle to the end. As you can see in our example, Healthy Fish Farms produces northern pike fingerlings for recreational pond stocking. They've divided their procedure into 11 steps from broodstock collection through distribution of the fingerlings. The second page of the HACCP process, entitled the Potential Hazards Worksheet, identifies the potential hazards that might be encountered during the course of operations. The HACCP training manual defines a hazard as an AIS fish or other aquatic vertebrate, invertebrate, plant, or pathogen that may be spread to a new water body, or, in the case of your farm, be spread to a new part of the fish farm. The owners of Healthy Fish Farms have identified several invertebrates, plants, and pathogens that they currently face. Keep in mind that the biosecurity plan is a living document and should be revised as new invasive species and pathogens are encountered or suspected. Let's continue on to the hazard analysis worksheet. In this step, we will look at each activity identified in the product procedure flow from page 1 and answer some questions about the hazards we might face. In workflow step 1, we've listed 5 potential hazards, indicated they are significant in this step, and justified our decision by indicating that they are present in the broodstock pond. We've listed control points or measures that can be applied to prevent the significant hazards, and finally made the decision that these are not critical control points. This brings us to our first question. What's the difference between a control point and a critical control point? A control point is any step in the process at which a hazard can be reduced. A critical control point is a step where hazards can be effectively eliminated or control can be best achieved. HACCP plans can lose focus if control points are unnecessarily identified as critical. There should be only 1 or 2 critical control points for each of the hazards listed. While ordinary control points may be helpful to attain your goal of eliminating AIS spread, for the purposes of your biosecurity plan, they do not need documentation, saving you time and paperwork. Let's continue to workflow step 2. We've determined that during spawning, the AIS plants are no longer a significant threat, so no control is necessary. The invertebrates and pathogens are still considered hazards, but the controls we've identified are not critical control points. In workflow step 3, the pathogen VHSV is a significant hazard, but can be effectively eliminated by iodine disinfection of the eggs. This is the first critical control point we've identified, and we will deal with it later on the AIS HACCP plan form. Workflow Step 4 has critical control points for all of the AIS we encounter. One tip to keep in mind is that disinfection procedures are almost always critical control points because of their effectiveness and your ability to document this part of the process. Workflow Steps 5, 6, and 7 do not include any critical control points. Even though there are significant hazards, they are not dealt with in these steps. Pathogen testing and fish health inspections are steps where you are likely to find critical control points. In Step 8, we see test results for VHS that determine whether the fingerlings can continue with grow-out or be destroyed. This is certainly a critical control point. Steps 9 and 10 include disinfection procedures that are critical control points. And finally, in Step 11, we see a control point to reduce the risk of spreading zebra mussel veligers, but we do not consider this control critical. In summary, our analysis has found 13 control points, only 5 of which were considered critical control points. Now we'll deal with each of these critical control points on the AIS HACCP plan form. Going down the columns, we've listed each step that contains a critical control point, the significant hazards we are trying to control, and what limits we are willing to accept to consider our control successful. Usually, this means elimination of the AIS from the process, but occasionally the best we can do is significantly reduce the risk. An example of this might be an invasive fish like gambusia that are found during minnow harvest. It's not practical to hand sort each of the fish coming out of the pond, but having critical control points to remove the gambusia at harvest, during holding, loading, and delivery will greatly reduce the AIS spread. Continuing down the column, we find the particulars on monitoring the success of our biosecurity plan. We will monitor the presence of AIS invertebrates in plants, as well as the concentration and duration of the disinfection treatment by visual inspection and measurement. This will happen each time we spawn, and it would appear that somehow I was assigned the responsibility to do the monitoring. Monitoring and recording the limits of the control measures should be the responsibility of a person on site at the time the control measure is being applied. If we find the presence of AIS invertebrates or plants, we will remove them, and the eggs will not move forward in the process until they have been disinfected. We verify the procedure by recording the absence of AIS and the disinfectant concentration and duration on the egg lot checklist. It's critically important to the success of your biosecurity protocol to document the actions you have taken to support your critical controls. Have checklists available at the time the controls are being implemented and keep them filed and organized. Failure to do so will make it virtually impossible to take corrective action should a biosecurity break occur. The other 4 critical control points we've identified follow the same pattern of identification, monitoring, and documentation, and you can review them on your own. Now that you've seen how a HACCP biosecurity plan is developed, you'll be able to use the examples we've provided to assist you in assessing your operation and developing your own biosecurity program. Once you develop a plan, review it with your veterinarian, state fish health specialist, or extension specialist to ensure that your program will be an effective tool to protect the investment and reputation of your aquaculture operation. Additional information and training in developing AIS HACCP plans is available through the Michigan Sea Grant Office. This DVD was written and produced by Jim Held and Sarah Kotz of the University of Wisconsin Extension. The authors wish to acknowledge the numerous agencies and private fish farms that assisted in the regional HACCP biosecurity training programs, and especially thank Ron Kinnunen of Michigan Sea Grant, Glenda Dvorak of the Center for Food Safety and Public Health at Iowa State University, and Ron Johnson of the University of Wisconsin Extension for their valuable participation.